Okay, welcome back. At this point, we're going to go on to that second bullet point in the lesson, which is average rate of change. Okay. Now, I said this in the introductory part, but it's important to just remember and circle back to it here. When we get to the calculus section of the course, it's important to remember that calculus is the study of the instantaneous rate of change of a given function. To build up to that, we need to look at what an average rate of change is. But just to get us oriented before we get to average rate of change, we're going to take a little sidebar to linear rate of change. Just building on concepts that you've had in the past. So you might remember that in the linear world, y was equal to mx plus b. Of course, y and x are our variables. X is the independent variable, y is the dependent variable. And we had two numerical values, m and b. B, of course, was our y-intercept, and m was our slope. Okay, all basic algebra information. Out of those two, between the slope and the y-intercept, which of those is a rate of change? The other way to think about that is which of those is a rate, and of course, we're going to come up with an answer of slope. Remember, slope was a comparison of two numbers. In English, it was rise over run. We also had a formula for this. Rise on our graph are the y values. Running from left to right on our graph are our x values. So we had something like y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And we can even have some shorthand for this, that our slope was, we talked about this before, our delta y, the change in y, over our delta x, our change in x. Now what's important about this is to remember when we have a linear, that linear function does change at a specific rate. It's a constant rate. In that case, the rate is defined by our delta y over delta x. Now with that basic understanding, what we're going to do is we're going to create a function, or excuse me, a graph that is non-linear. So let's just draw an x-axis and a y-axis. As we draw the x-axis and the y-axis, let's create a parabola since we're dealing in the world of parabolas now. And then we're going to put a handful of points, maybe 4 of them, on the x-axis. This first point will be A. The second point we're just going to call B. Over here, we'll call this x value C, and a fourth x value D. And of course, you can draw a vertical line straight up so you can see where those x values cross our particular graph. So here's my question for you when we're talking about rate of change. If we were to draw a line segment on our graph between A and B, and a line segment on a graph between C and D, which of those has a greater rate of change? Another way to ask that question is, which of those lines has a steeper slope? From A to B, our slope is relatively flat, but when we get to C to D, our slope is a lot steeper. With that being said, we could say over here between A and B, we have a lower rate of change. And over here between C and D, we have a higher rate of change. Okay. So we're building up again to this whole understanding of average rate of change. So far we've looked at linear rate of change, which was our slope. We've taken that linear and kind of superimposed that upon a curve just to see the concept of rate of change between two particular areas. What we want to come up with now is just a very simple understanding based off of these, is that you can take a function, and again I'll try to draw here an x-axis and a y-axis, and our function can be rather complicated. It can increase, it can decrease, it can increase, it can decrease, it can go to negative, it can increase, decrease, increase, decrease. We can do all sorts of different directions. If our starting point is here, and our ending point is here, we might ask the question, what was the average rate of change through this particular period of time? Now, one aspect or one place that you might see this in the business world is in the stock market. And of course, if you followed the stock market, you would see ups and downs, ups and downs. Of course, you wouldn't get a negative. You might go to a zero with the stock market. But at the end of the year, when you sit down with your financial advisor, you want to know what your rate of return is. That rate of return is nothing more than the slope of what we would call a secant line. It's the slope of the line that goes from the beginning of our year to the end of the year. We want to know how much growth we had over the course of the year. Now, what's important about this is we really don't care about what happened in the middle, because it all averages out with an average rate of change, looking at the beginning and at the end. So when it comes to an average rate of change, I'm just going to use delta here. That average rate of change is the slope of the secant line. We're just going to draw a line between our first point and our last point and calculate the slope. This will have an x and a y value. This will have an x and a y value. We can say m is equal to our delta y over our delta x, and we're good to go. This is the formula that we're going to use to calculate our average rate of change. And you will see this later on when we get to our word problems.